Welcome to the Stratasys webinar, Leveraging Additive Manufacturing for Factory Floor Tooling. Today, we'll be talking about how 3D printing can help you produce more, increase quality, and reduce costs of your jigs, fixtures, and manufacturing aids. As a clarification, the term AM will be used to refer to additive manufacturing throughout this webinar. We'll start out by talking about traditionally manufactured tools and some of the challenges they pose despite their being considered the standard. We'll then look at AM tooling and the many benefits it offers. Following on from that, we'll take a deeper look into the specific factory floor applications and the types of tools that AM is a good fit for. Then we'll move on to FDM Technology and explain what it is and why it is a great fit for these applications. From there, we'll take a look at the Stratasys Printer and Material Portfolio and how they factor into the making of jigs and fixtures. Finally, we'll give you some social proof and talk about a few customer success stories. So let's get started. Jigs, fixtures, and manufacturing aids are indispensable tools in the production process, but when we rely on conventional methods to make them, usually machining or perhaps injection molding, conventionally made tools have their downsides. Machine tools and the molds to make injection molded tools are typically costly to make. They rely on skilled machinists and are limited by traditional manufacturing constraints. A lot of material is also wasted in the subtractive machining process. Turn time is typically pretty slow. Whether they're made in-house or outsourced, there's usually a backlog that has to be worked through before you have your tools in hand, ready for use. When they're made from metal, they're usually heavy and not necessarily easy to manipulate. That puts a strain on the workers who use them, and it slows down the production process if accessory tools like cranes and hoists are required to move and position them. Often, they're comprised of multiple parts that require assembly. These parts all add to the weight and complexity. They're not usually designed with the best ergonomics, contributing to user discomfort or worse, repetitive motion injuries. As a result, all of these challenges usually limit the number of tools that are deployed to only the bare minimum required. But the reality is that more tools and more effective tools can actually benefit production. However, if they're expensive and time-consuming to make, there's limited appetite for producing more of them. But there is an alternative, and it's additively manufactured tooling. Additive manufacturing, or 3D printing as it's also known, presents multiple benefits for factory floor production. Compared to traditional tooling, AM tooling is typically less costly to manufacture. AM tools can usually be produced for lower costs since only the material that's needed to make the tool is used, versus machining, where a significant portion of the material is wasted during the machining process. AM tools can also be manufactured much more quickly than machine tools because this method avoids the time associated with outsourcing and/or machine shop backlog. Being able to deploy tooling faster means production downtime is minimized, which reduces overall production costs. Additive manufacturing affords greater design freedom, avoiding typical manufacturability constraints. This means your tools can be customized more easily for the specific task, which can ultimately improve productivity. When tooling costs are lower and tools can be manufactured quickly, it's possible to make more of them to help in the production process. Check fixtures, fit gauges, and similar tools that are more prevalent in the manufacturing process help maintain quality. Tools that are designed with both the user and the task in mind usually increases task efficiency. We have an example we'll show a little later where a 3D printed seal assembly jig shaved a small amount of time off the task cycle time. But because that task was repeated hundreds of times, the overall cycle time was reduced. Oftentimes, we tend to think of tooling in a limited way, restricted to our own area of responsibility. The truth is, tooling is used across the full spectrum of the production process, from incoming raw materials to shipment of the finished product. That means that there's a large potential to leverage the benefits of AM tools in each one of these areas that could result in cumulative savings across the manufacturing process. To break this down a little, we can consider tooling to fall under four broad categories: production and assembly, shipping and logistics, quality, health and safety. In the following slides, we'll take a look at specific tooling applications within each category and go a little deeper on how AM tooling can impact each of those areas on the factory floor. To start off, we'll look at production and assembly. Production and assembly tools provide one of the largest opportunities for reaping the benefits of AM tooling, primarily because of their prevalence in the manufacturing environment. Alignment tools, holding fixtures, milling fixtures, drill guides, end of arm tools, even paint masks can benefit from additive manufacturing, with the benefits we just talked about in the previous slide. The images on the slide show a robotic end of arm tool use case that was made much lighter, much less bulky, and optimized for the job. The picture on the left shows how it was made using traditional machined steel. The picture on the right shows the 3D printed tool. The result was a 95% weight savings, or reduction by 32 pounds, and an 85% turn time savings, which equated to 17 days saved. Additionally, the 3D printed tool incorporated internal vacuum channels, eliminating the need for external vacuum hoses in the vicinity of the cutting water jet. The lighter tool made it very easy to handle and install on the robotic arm compared to the steel end effector, and also meant less wear and tear on the robotic actuator motor. This is just one example of how FDM technology provides real benefit in the jigs fixtures tooling space. Sometimes overlooked, but just as important, are manufacturing aids that help organize parts and tools as well as transport parts through the production process. This includes bins, trays, racks, and assorted devices that maintain organization. Making these items with AM affords the design freedom to easily customize them to the part or tools they carry. The design freedom of additive manufacturing makes complex designs possible where an equivalent machine tool would be too time-consuming, expensive, or even impossible to make. FDM technology also offers an inexpensive, fast alternative to thermoforming molds for packaging and/or the production of nested carrying trays. This avoids the typical expense and lead time associated with producing machined molds. Better organization helps streamline the production process, and protection of parts through that process minimizes damage. Similar to production tooling, inspection tooling reaps the same benefits from additive manufacturing. Tools can be produced and modified as needed, faster, and for a lower cost. Typical opportunities for these tools include CMM fixtures, fitment check tools, go, no-go gauges, and even stand-in surrogate parts to validate assembly or inspection processes before the production parts are available. The ease and low cost of AM tooling makes it easier to incorporate more check fixtures and inspection tools in the production process, potentially reducing errors. The top picture shows a first article CMM fixture developed by Oric, maker of household vacuums. Previous first article inspections were handled with modular aluminum clamps that held the part to be measured in place. Combined with the resultant CMM programming, this setup method took roughly 30 days to test all of the first articles for a new vacuum model. Oric switched to accurate FDM CMM fixtures and reduced the entire inspection process down to a day. On top of that, Oric 3D printed accurate prototypes to serve as a surrogate part before production parts were available, further streamlining the inspection process. Because additive manufacturing can make things faster and for less cost, it's a perfect solution for making tools more prevalent on the factory floor that enhance worker health and safety. In many cases, AM tools can be added to the inventory where there previously were none before due to cost, weight, or other factors that made them impractical. AM provides an easy and fast method of creating safety guards and other protective devices specifically tailored to the worker and/or task. Making tools with FDM thermoplastics enables the use of strong but lightweight materials. This means tools can be made that weigh a fraction of metal tooling. Lighter tools can reduce or eliminate injuries, strain, and lost work time due to repetitive use of heavy, bulky tools. Tooling that's easier to use and manipulate also helps reduce task cycle time, which ultimately can reduce overall production cycle time. The pictures on this page show one example of an automotive door seal jig that was redesigned for better ergonomics and made using additive manufacturing. The weight was dropped from 150 pounds to 28 pounds, making it much easier for workers to pick up and move. In addition, the tool reduced the task cycle time, resulting in a substantial productivity gain. FDM technology is well suited for jigs, fixtures, and other manufacturing tooling applications. FDM stands for Fuse Deposition Modeling, a process that builds parts layer by layer using a softened plastic filament pushed through an extrusion head. The main reason FDM is such a good fit for this application is because of the types of materials it employs, which are durable thermoplastics. In most cases, these materials provide all the strength you'll need to make jigs and fixtures, but they're lighter than their metal counterparts. They can be produced in a day, overnight, or less, which is a great time saver. There's also a broad range of Stratasys FDM materials available, so you can match the material to your specific application. If you need high strength, rigidity, good wear, chemical resistance, or low sliding friction, there's an FDM material available. We'll talk a little bit more about these materials in a couple of slides. In addition, there's an FDM printer for just about any budget and build size you need, from smaller tabletop versions to the full-size F900, capable of producing large tooling. I'll show you the lineup on the next slide. FDM is also one of the easiest types of 3D printing technologies to use. There's no hazardous equipment and/or substances involved like with other types of 3D printing technologies, and don't require sequestered locations or special handling. The beauty of Stratasys FDM technology is that there's a printer for any budget and job requirement, whether it's to make smaller tools or large fixtures. At the left end of the slide is the tabletop F120 printer. It's a powerful, reliable, but dead simple printer to use and is easily capable of making small jigs and fixtures quickly. It's part of the F123 series of printers, which includes the F170, F270, and F370 that you see on the chart. All the printers in this series are built with the same reliable platform and are backed by thousands of hours of testing and customer utilization. The small footprint makes it a good fit for offices, engineering labs, or a space-limited area of any factory floor. On the right side of the chart are Fortis printers and the largest FDM printer, the F900. These printers offer larger build envelopes and are capable of printing a wider variety of thermoplastics. The Fortis 380MC Carbon Fiber Edition uses ASA and FDM Nylon 12 carbon fiber materials exclusively. We'll talk a little bit more about FDM Nylon 12 carbon fiber in the following slide. At the far right is the F900 with a generous build chamber. Companies that already have an F900 and use it for prototyping or production parts sometimes overlook the fact that this printer is capable of making larger jigs and fixtures as well. In fact, customers have even made section tools, printing them in several parts and bonding them together post-print. In addition to a broad choice of 3D printers, you have a wide variety of thermoplastic materials to choose from. Many jigs, fixtures, and manufacturing aids can be made using standard commodity plastics such as ABS and ASA. However, if stronger, more durable materials are needed, engineering plastics as well as high-performance thermoplastics are available. In the engineering plastics category, one material that is particularly well suited for tooling applications is Duran. It is a very tough material that can stand up to the rigors of a factory floor environment. It also has a very smooth, slippery surface texture, which makes it a great candidate for tools that have any sliding motion relative to the workpiece. These characteristics make Duran a good overall tooling material. For more demanding tooling applications, there's our high-performance thermoplastic category. The Ultim plastics offer high strength and heat resistance. Our Antero materials are PEC-based, with one of the versions providing electrostatic dissipative capability. At the bottom of the pyramid in orange is our elastomer material. It has a pliable, flexible characteristic which makes it a good fit for applications where a non-marring interface is needed. We have automotive customers who use it as a locator jig to install badging on painted surfaces. And speaking of paint, other customers have used this elastomer material as a fast and easy way to make paint masks. You may be wondering about the process it takes to get to a printed part. GrabCAD Print is a software for Stratasys printers that simplifies the 3D printing workflow from CAD to final part. Add your CAD models to GrabCAD Print instead of exported STL files. CAD models are precise, capture the designer's intent, and make it available for defining your print process. STL is supported for printing, but CAD models get you printing faster and yield a better result. No experience, no problem. Choose your printer and material, then lean on smart default settings, tooltips, and notifications to guide you through a seamless printing process. And GrabCAD Print has a variety of advanced features that let you adjust the print qualities of your model, such as adding more material where you need more strength and less material where it's not critical. This helps optimize the time and amount of material needed to print your tools. Before going to print, work with detailed views of your model, printer tray, and slice preview so you can make necessary adjustments. Now let's take a look at some customer examples. Thogus is an injection molder that specializes in low-volume manufacturing and highly engineered materials. By 3D printing their factory floor tooling instead of outsourcing, Thogus achieves dramatic cost savings. In one particular example, Thogus produced a 3D printed CMM fixture overnight, saving 70 to 90% on lead time compared with outsourcing. As an example, one fixture was quoted for $1,500 from the machine shop. Thogus 3D printed it for less than $200 in materials. Stratasys is a tooling supplier to the transportation industry. They redesigned and 3D printed a jig used to assemble automotive door seals that shaved 4 seconds off each assembly cycle. That doesn't seem like much, but at a utilization rate of 250,000 cycles per year, the result is a labor savings of over 270 man-hours. The original 150-pound weight was also reduced to 28 pounds, making it much lighter and more ergonomic. Polaris uses FDM technology in a variety of tooling applications, including badging and part locating fixtures. Previous methods involved the use of leather and vacuum form parts to do these tasks, but they were time-consuming to produce. One particularly effective tool includes locating fixtures made out of TPU, which is an elastomer. Its soft, pliable surface texture doesn't mar painted surfaces. Jigs, fixtures, and manufacturing aids are often overlooked as an application for additive manufacturing, but this application offers low-hanging fruit and an area where significant savings and productivity improvements can be made. Get a hold of us to learn more about these kinds of opportunities. We can help you better understand the printers and materials that are right for your application. Finally, 3D printing covers a lot of ground and provides a lot of solutions for prototyping, designing, tooling, and manufacturing production parts. Discover what's available in the Explore section of our website. You'll find case studies, videos, white papers, and other helpful information.